All right, so let's keep going. So here's an initial attempt at a class diagram. And we're going to work through some of the requirements, some of the reinterpretation of what we were reading. Maybe we misread a couple things. We misinterpreted some of the requirements, which led us to come up with this first approximation. So we'll revisit some of the phrases in the narrative. In some cases, there might be, instead of being two nouns that were connected with one verb, it was actually a verb phrase that contained three nouns that were related to one another, or four nouns that are actually related to one another. Okay, so that would take us to a complete different interpretation and implementation for our data model. So we'll just point those out. We'll also point out some alternatives. What if the text would have said this, right? And then how would that drive our design one way or another? Okay, so let's take a look at first. Some of the relationships that perhaps might be interpretation that we oversimplified our understanding of the text, right? So, for instance, there might be some redundancy, some inadequate relationships based on our interpretation of the text. So, for instance, here. We might read the text once more, and we saw these two particular nouns, right? Students and grades, and we only focus on the receives verb, right? It says, that student receives grades, right? And that kind of drove us to create this student and grade, right? Student receives grade. Right? That's where the relationship came here. But if we look at the actual text and we revisit it, we actually realize that there was more to it than just the student and the grade. There was a for qualifier in there, right? That says that not only is the student related to the grade, but there's something else in the relationship, right? It looks like it's enrolled in a section. So that says that the relationship is not just between the student and the grade, but it's a relationship between the student, the grade, and some enrollment in some section. Okay, so there's three nouns here that are related to one another, not just two. Right? And we don't seem to capture that here. We know that there's a student is related to the section, but notice that the section has no relationship to the grade, right? And that somehow the grade is related to the section, but there's no relationship to the student. Okay, so somehow we're missing something in there. Another one there says professor assigns grade, right? There were two nouns and a verb in between, but this would have been an oversimplification of our interpretation. We realize that if we read it again, it's really professors assigned grades to students in the section, right? So the verb phrase is actually a little more complicated, right? There's actually not just two verbs associated, just professors and grades, but professors, grades, students, and sections. There's four nouns related in that phrase. Okay, so if we reinterpret that, we see that there's a multi-way relationship. No, it's just not just between two, but the relationship goes across three or four or even five different nouns, right? So it's just not student and grades. There's something here missing in there, right? Or professor assigns grade to student and section. Looks like there's three or four nouns there that are related. So it would look something like this instead, right? Where we would have some node here that relates all three together, right? That a student and if giving a particular combination of a student in a particular section, there would be one grade associated with that combination. Right? If I know who the student is and I know what the section is, there can only be one grade. Right? So this tries to capture that. There's no way to capture this as a relational database. Right? So we typically what we do is that we convert this verb. Right? We convert the verb receives. We convert it into a noun representation. That can allow us to capture the actual relationship between the three entities, right? So here's a grade assignment, right? So this receives, what we call it, we are reifying, right? There's no physical way to represent this in a relational database, right? So we look for a concrete way that we could possibly capture that in a concrete table that would have maybe foreign keys to all the other entities involved in that relationship. Okay. So again, there would be three foreign keys pointing to grade, section, and student, right? In a particular part of in a particular record, right? Relating all three. All right. Okay. So going from this conceptual representation to a more concrete representation, we call that to reify, right? To make it more concrete. Right? This is way too abstract. We make it into something that can actually be converted into a relational schema. Now the transfer, the conversion is not straightforward. Notice that in the original representation in this conceptual model, we're kind of enforcing the fact that for any one combination of section and student, they can only ever be one grade, right? And this one grade per student per section, right? But this, when we convert it into a reify, we kind of lose that fact, right? That because this one is not enforcing the fact that for the same combination of section and student, you could have a different grade. All right. There's no so this particular is kind of missing that part, right? So there's not a one-to-one capturing of the same constraints that we have in this model that is captured in this other model. But there's nothing we can do. This will eventually, right? So notice that we're kind of going towards where? We're kind of going towards the end result, right? That eventually this will become the enrollment table, right? That's where we're going, and as we go towards that, notice that at some point we're gonna capture and make the decision that it's not worth having a whole table just to capture the grade. There's only what? There's only 10 values, A, B, C, D, right? Those are the possible grades. We're not going to repeat them, right? It's kind of more like an enumeration as opposed to just being records, right? So eventually we're going to decide to bring this class, right, and bring it into this record over here and just making it an attribute instead. Right, just capturing, even though it'll repeat itself multiple times, A, B, 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 A, multiple times, right? That's okay, right? It would have been almost like a enumerated data type anyway. Okay. Right. So reifying is that we were able to convert it into a more concrete representation of that can actually be converted into relational schema. It typically happens when we have a more than a binary representation, right? Like a three-way or four-way is a more common use. All right, so let's see. We went from our first approximation, and we replaced grades, student, and section, right? We kind of replaced it with this one grade assignments, right? That has references to the section, the student, and the grade. We're also capturing this assigns, right? The fact that it's the professor who assigns the grade, right? So we replace it. We kind of put something in the middle of that diamond there somewhere, polygon, right? That relates all four. Okay. All right. So if we go a little further, this says, consider the query that says all sections a student is enrolled in, right? That's one of the queries. One of the requirements at the beginning of the narrative was that we wanted the administration to be able to ask, what are all the sections that a particular student is enrolled in? That's one of the questions. Let's see. Right. So there's there's two ways that we can answer this question, right? Depending on how you navigate in the class diagram, we can answer, going from the student to the section to the grade assignment, or we're going through the enrolls relationship. So let's take a look at that. When we have, all right, so here's an example of navigating either from the student to the grade to the section. So because you have two ways of going either to students enrolls section or students grade assignment section, these two, right? Where's enrolls? Yeah, so you can go either from student enrolls in section, right? Or you can go student grade assignment section, right? You can answer the question on which students are enrolled in which section, right? Either following this relationship here, or you can answer it going this way, right? Where you can say that the foreign key maps to a student and the foreign key maps to a section, and you can join these two to answer what students are in what section, or just following this enrolls relationship here. Because there's two ways of answering this query, right? We usually refer to these of one of them being redundant. Okay, remember that we don't want to be able to answer the same question in 2-3 different ways, right? Kind of the analogy I mentioned earlier. If you have two watches, if you query what the time is, they both should give the same time, and most of the time it's true, right? But over time, right, either because I either updated this relationship here, and now if I ask it here, it'll tell me the truth. But because it might be different if I go this other way, I might get a different answer. Okay, so two ways of answering, because they might deviate at some point, right? For any reason. We want to eliminate and only keep one way of doing it. We either remove this relationship here, or we remove this other relationship here. Okay, we're going to probably end up just removing enrolls in here. Another fact here, you have another redundant relationship here. We have assigns, right? The professor assigns the grade. But you can also answer the questions this way, right? You have a grade assignment section and then the professor, right? So it's redundant to also point to the professor from this grade assignment. So we decide to remove it, right? We can determine who, because we already know who teaches the professor. You can't have one professor teaching it, but another professor assigning the grade. It makes no sense, right? So it's enough to go this way to determine who the professor is that assigned the grade. Right, because it could be only the person who is assigned to the section is the same one who assigned the grade. There's no point of pointing to the professor going this way. Right, so we remove the assigns relationship there. But not all cycles. It looks like it almost seems that if it's a cycle, it's going to be redundant. Not necessarily. Okay, notice that in this case, one of the questions that we might ask is, what if I give you a student? Can you tell me what department are they enrolled in? What college? What's their major? Okay, and you can answer it in a couple of ways. You can answer. You have the department, and you have the course. If you give me a student, I can tell you what the department is, right? If I tell you the department, I can tell you all the students, right? But notice the other cycle, right? And it's your responsibility to, depending on all the requirements, or all the questions that you want to ask the database, to walk all the cycles, right? To walk all the paths, to see if you're able to answer the same question in two different cycles, right? Here, notice that if you walk this cycle, even though it might look redundant, it's not, right? Because by the time you get from student to grade assigned to section to course, when you get down to course, you've kind of lost what particular student you're talking about, right? By the time you get to course, there's no information about any particular student, right? When you get to here, you're talking about a whole bunch of students across multiple sections. There's no way to refer to any particular student to be able to answer if any particular student is in any particular department. See that? Right, so walking this cycle here, right? You can't answer the question, given the student what department they're in. You see that, right? So again, it only depends on the question. Yes?
Is there like an unwritten rule that says don't go this far?
Oh, no. It's not that. It's that when you... Do I have an example?
So far away,
Oh, no, I don't have it.
can't do
Well, no, but when you get to this point, right, this course is related to a multitude of sections, right? And this section is related to a multitude of students. So by the time you get here, you have hundreds of students, and there's no way to identify any one particular student. Okay, so you could not answer, given a student, tell me who the department is, right? You could tell me, given these hundreds of students, what are the departments? That's a question you can answer, right? And probably tell you, well, all the departments, right, across multiple students, right? So in this case, even though it looks like a cycle that you could traverse it in both ways, it is not a redundancy. This cycle is okay, right? For that particular question, right? If the question would have been, can you determine what are all the departments that all the students are in? That's way too broad a question, right? You can answer both ways, but that's not the question, right? The question is, given a student, can you tell me the department? Yeah. So the fact is that you need to walk, depending on the requirements, you need to walk all the paths, and depending on the question, you can decide whether it's redundant or not. Okay. And you need to remove the redundancy. So anyway, so we removed enrolls, right? The enrolls that we had here, right? We removed the relationship between the assigned and the professor. It's no longer there. And we just have grade assignments. And this is the kind of analysis that we're looking for in your assignment, right? First give me a first approximation, a naive implementation of a class diagram. And as you analyze and make decisions, you say, oh, well, I don't really need this line over here, right? I don't really need over there, right? I'm going to group these three into one. This used to be a class, but I'm going to make it an attribute. Right? So that's the kind of analysis we want from that first data analysis assignment. So let's keep going. Right. So the algorithm that we had looked at earlier only dealt with one-to-many, right? It didn't deal with many-to-many, right? And so we'd like to maybe explore some of those ideas. For instance, based on the description of a narrative, one student can only be in one department. Okay. And that's why we started the way we started in the naive first approximation. But what if the what if the requirements would have been that a student can have maybe a major and a minor, right? Or like a double major or something like that, right? So that we're allowing folks to be registered in more than one department. So we could have decided something like this instead, right? A many-to-many. One student can be in many departments, just like one department can have many students, obviously, right? Certainly we have the one-to-many, but now we're allowing the other way, many-to-many, going back to the department. So we could have decided something like this, or we could have decided if we want to give a limitation, we could say that this can be 2, 3, right? You can't have more than 3, right? So it could be 1 through 3, so this could be 1.3. So you can have a minimum of 1 department, but a maximum of 3. Right? It could be 0.3, meaning you could be undecided. So I don't belong to any particular department, right? But then I can then be enrolled in 2 or 3 departments and do a triple major. So if that's true, notice that the many-to-many in the algorithm, doesn't deal with many-to-manys. Okay, and also we need to consider the fact that there's no way for us in SQL in a relational database to capture a many-to-many. Okay, we only have one foreign key referring to one primary key. You can't have one foreign key referring to multiple primary keys. There's no such thing. Okay, the primary key is not multi-valued, right? You can only have one record, have a foreign key to one single primary key. So there's no way to implement this in a relational schema. So usually we convert it into a mapping table, a table in between that has foreign keys that points to both of them, saying that, hey, that record over there is related to that record over there. That has two foreign keys going back. So we usually refer to this as a reifying, right? We create a concrete thing that we can actually represent it and run our first algorithm. Remember the first algorithm? Or second, I forget. That would convert this into a relational schema. Okay, an equivalent relational schema. Measure creates an equivalent. Yeah. So another example where we might capture, if we have a many-to-many, what if we want to capture also the GPA, right? If in the one-to-many relationship, it makes sense to capture a single major GPA, right? Because you are enrolled in a single department, you only have one GPA, right? But what if you are enrolled in multiple departments? Yes? If you're enrolled in multiple departments, notice that it's not enough to just go from 1 to star, right? Now that you can be in multiple departments, this relationship up here, right, where it used to be that one student can have just a single GPA, no longer holds, right? We would be tempted to do something like this, that you can have multiple GPAs, right? One per each department, yes? But notice that there's no enough information to know here what GPA belongs to what department, right? Yes, I have these GPAs, but there's no capturing here of for which department do you have that GPA. See that? Here it was obvious because you were only in one department, right? You could answer that. What's your GPA for the department? Well, I only have one GPA. Over here, I can have multiple. So how do you capture that? So that means that we have to move that somehow here, right, and relate it to the department somehow, right? We have to move it over now that the requirement says that you can be in multiple departments. So here's one way to capture it, right? We now have realized that it's a three-way relationship, right? You give me a department and a student, and I can give you that GPA. If you give me a different department, I need to give you a different GPA, right? So the combination of student and department give you one GPA, right? But we can't capture that in SQL. We can't capture it in a relational database, right? A three-way relationship, there's no such thing we can capture in UML. UML holds everything, right? You can do anything. That's an association, right? Whether we saw earlier, UMLs can do that, yeah, sure. But you can't convert it into a relational schema. So to do that, we're going to reify again. We're going to replace the verb, right, with a noun, right, a student major that makes a relationship that says, okay, this points to a student, to a department, and that's a GPA. Meaning that for any combination of student and department, I have a GPA for you. Okay, so that's reified. Or how about the fact that not that you can be in multiple departments, but that you could be undecided. I don't know what I am. I don't know in what department I'm in, right? So this relationship now becomes optional, right? I could have a department, or maybe I don't have a department, right? So in that case, this also would need to have to be also optional, right? If I am in a department, I have a GPA. If I'm not in a department, then I don't have a GPA. Okay. But what if that becomes now a many-to-many, right? Where now the department is optional, right? I can have 0 or more departments, right? So meaning that if I am in a department, if I don't belong to any department, I don't have a GPA. If I belong to one department, I have only a GPA for that particular department. So maybe I have a GPA, maybe I don't have a GPA. So how do I capture that? So that could be captured as follows. We can revisit the student with major table, right? And instead of having a one-to-many here like it was before, right? It could be a one-to option, right? So this whole thing is optional, right? If I am in a department, right, then this is a 1. I have a department, and for one department I have that one GPA, or maybe I don't have any. I'm undecided, I haven't joined any department, and this whole thing doesn't exist, right? I don't have a reference back to the student because there's no record here for that particular student up until I join a department, and then I have a reference to the department, to a student for a department and for a major. Okay. So again, those choices are for whatever requirements are in the narrative. So anyway, so those were kind of like tangents, right? What ifs, right? But let's go back to what the actual narrative said, that there's only one department and multiple students, right? One to many, right? Not a many to many. Let's see. Notice that we have replaced the table, right? That did the sections and the student. We replaced it with the enroll table. Let's focus a little bit on this left-hand side on the permit, right? Where we might say that the department, the permit is optional, right? With the permit, I might have a permit, maybe I don't have a permit, right? If I want to be able to park my car here, I need a permit. Otherwise, if I don't apply for it, I just don't have a record for it at all. Also, depending on whether I'm a student or a staff. Right? If I'm the permit for the students expires, so every year you have to apply for it, as opposed to a staff doesn't expire, right? So how do you capture the fact that some of them expire, some of them don't expire? So for instance, if the permit is optional, right? We can declare it like this, 0 or 1, right? Permit. There might be a permit. There might not be a permit. If there is a permit, there might be an expires on. That there might be like various expiration date where in a particular expiration date, multiple permits will expire, right? And this depending on whether you're a staff or not, you either have an expiration date or you don't, right? So if you have a student, you have an expiration date. If you're not a student, you don't have an expiration date, right? Also, over here, the list of the license plate and car model. This could be, you could argue that the license plate is kind of like an enumerated data type. That it would be enough to capture that just in the permit as just a string attribute, right? As opposed to being its own class, right? A whole bunch of records with those license plate. And that's since it's a one-to-one. You could just as well just live inside of the permit. Now, depending on whether you're a student or a staff, right? We might capture that if you do have a permit, then you have an expiration. If you don't have a permit, then there's no need to capture the expiration date. And I don't know if you have a staff. Oh, I don't have a staff. No, I don't have a. Yeah, I don't have a staff example. Let's see, university student. Now, if you might be required to have a permit regardless on whether you have a, and so that you would have a one-to-one, right? You're already given a permit at the beginning of the year. You actually even paid for it, right? And whether you use it or not, that's your business. But you're given a permit at the beginning of the year. And we might decide that we might merge the attribute of a permit into the student, since it was a one-to-one relationship. That we might decide that the permit is not enough to live in its own class. That it's just enough that it could be part of the student class, and it gets merged into the student. And then the student would just have a reference back to the license, and the car reference back to the student. And again, you can argue both ways whether it's enough to just capture the student and not a permit. Right. So there you could argue both ways about attributes or classes. Also, how granular you want to capture the information about the permit. Is it enough to capture the color of the car, the make and model of the car, the license plate? How granular you want to be. for instance, the professor, we decided that for capturing the professor, it was enough to capture it as an attribute of the section as opposed to a whole class, right? We're just going to capture the username of the professor, and that's enough, right? If the requirements would have said that the professor has a whole bunch of grants, and they have an office, and they have office hours, and where would you capture that? Well, for that you would need records, right? It wouldn't be enough for them to be attributes, yes? But the way we read the narrative, there wasn't any of that, right? There was no mention of the professor other than perhaps their name or their username, right? So we decided to just go and capture the professor. Professor weren't important enough to have them as records, right? As individual records, and that might be okay, right? Depending on the implementation. Right. So it might be that nouns that at some point in your when you were interpreting the narrative, you decided that there were classes. After reinterpreting it and reconsidering, you decide that this class should actually be an attribute, right? But this class probably is related to a whole bunch of other classes. Yes, it might have that it has a whole bunch of relationships, right, going off from this class that you want to now remove and put in an attribute. What do you do? What do you do with those relationships? Well, what you can do is for any class that you're considering converting into an attribute, you got to look at all the associations that it has with other classes, right? So you need to basically that one class that you're removing, they would become attributes in all the other classes that it was related to. Okay. So for instance, if you have the year, notice the year here, right, that we were capturing as a class, right? Notice that it has relationships to the section. It has relationship also to the student, right? So if we want to remove it and say, hey, we could merge this into a section and say, what year it was offered, and then what year the student graduated in. Well, this could just be an attribute in the section table, and it could be an attribute in the student table, right? As opposed to it being, an entire class or entire table, right? So those can be merged. Same thing with the professor. The professor can go as an attribute of the section. The license plate could go into the permit. The car model could also go into the permit, right? And things that used to be classes, they can become now attributes, right? And license plate too, yep. And you end up, lo and behold, you end up with where we wanted to end up, right? This was the best design that we started at the beginning, right? We started with the permit, the student, the department, the course, and this is the original class diagram that we introduced last week, right? And that was the intent, right? To reach to the point where we have begun. Notice that there's a whole bunch of attributes here that are missing, right? Oftentimes in your narrative, a lot of things will be left implied. Right, they won't be listed explicitly. The fact that people have first names and last names, right? That people have usernames and passwords, right? That courses have a title. Those kinds of things might be implied. It might not be explicitly written in the narrative. So you need to kind of go back and fill in all those things, right? That are obvious. They were so obvious that they were left out from the narrative. Right, so you have to go back and courses have titles, departments have titles, the students have names. So we're filling those things in that might have been obvious. And also you need to start looking at cardinality, especially when you were converting things that used to be classes and now are becoming attributes, right? And they used to be multi-valued. You have to also consider the fact that how are you going to capture that now? There's going to be an attribute. Is that going to be an array now, right? If this used to be foreign keys that refer to professors, right? If you bring those in here, right? Now you need to capture that in some other way if it's multi-valued, right? Especially if it's a many-to-many. So you would implement it using arrays, right? Arrays of elements. So it would be maybe a list of professors, right? If you have multiple professors teaching the same course or the same section, right? They would be represented. There used to be foreign keys to one record referencing multiple records. One for many foreign keys referencing the same primary key. But if they're brought into as attributes, they would have to be captured as arrays. Aggregation. Again, when you want to be able to capture the fact that there might be a life cycle dependency or not between multiple classes, where you might have a record for a car, you might have records for engines, you might have records for orders, and notice that there is no life cycle dependency between these two, right? You have a record of an engine, and you have a record saying that somebody ordered that engine, yes? But if somebody cancels the order and I have to delete the order, not necessarily do I delete the engine, right? Okay? So there's no life cycle dependency. If I remove this record stays, right? There's no need to remove it. Same thing here, right? If I might have a record of an engine and I might be building a car, right? But I might decide, somebody ordered a car, and I'm recording it. If I decide not to build the car, well, I might still have the engine, right? I'm not necessarily removing the record for the engine if I decide not to build a car. Well, this is a little dark. If I have no persons, I don't have legs and hands. I don't like this example. Generalization. So here's one that might be a little harder to model or to capture as a relational schema, where you have a base class person, and you might have students and professors inheriting from a base class, your name, age, date of birth, and things like that, that all persons have, and professors and students inherit. So how would you convert this into a relational schema? Right? So we have not talked about that at all. Here's another example where you might have a person. I'm sorry. This is the way. This is one of the ways that could be implemented. One way would be to have, for each class, you could have a separate table. Right? That's obvious. Right? This is the most naive way of doing it. Typically, it's not implemented this way. But this is one legitimate way of implementing it, and notice that the base table, I'm going to call it the base table. Notice that it captures all the fields that are common amongst everyone, right? So which is name and age. There it is. And notice that the person also captures the attribute that is only specific to that particular record, right? That particular class, office, right? Office. And same thing for the student. They have particular grades, right? It's an array. Yes? Okay. But notice the trick here is that these tables, notice that their primary key is also a foreign key. See that? It's a foreign key back to the person, and the student also, its primary key is a foreign key back to the person. See that? All right. What this is saying, right, is that a professor cannot exist without being a person, right? If I remove the person record, right, I have to also remove the record that goes with a professor. It makes no sense to have a record of a professor without also having, right, an equivalent or related record in the person table. See that? Right? And that the data is being split off into two tables. Half of the information is going to live on the person table, and half of the information is going to live on the professor table, right? And that if you ever want to, talk about the professor, you would have to join both tables, right? You would have to retrieve some of the data from one of the tables and some of the data from the other table, and then you can talk about a professor or a student, right? That one has to exist with the other, right? These records are tied. Right, they have exactly the same value as a primary key, and this one is a foreign key back to the person. Right, so that's one way of implementing foreign keys. inheritance. Here's another example. Here you have a faculty which has one-to-many courses, and then you have a student enrolled in multiple courses, and a course has many students. And notice that the TA is also a student, right? Is also a student. So it inherits all the attributes of a student, and it's assigned to any courses, right? So one course might have multiple TAs, but one TA for multiple courses? Wait a minute. Yeah, I guess so. So how would you capture that? Well, the schema might look something like this. You would capture the faculty, right? The ID, the primary key for the faculty and the office. And here's the course, right? The course might also, the number of the course, the name of the course, taught by is an integer, references faculty. So this is a foreign key, yes? There's a foreign key saying that that particular faculty is teaching this course, right? And that's from this here, right? Teaches, the one-to-many, right? Notice that the course, according to this, has a foreign key referencing the faculty. Right? That's what the star means. Let's look at the student. The student is also just a plain old table. But here's the inheritance, right? The TA has to be a student, right? You cannot talk about a TA without the context of it being a student, right? It has to be a student. So half of the information of the TA lives on the student table, and the other half lives here on the TA table. Right? So notice that the primary key, the ID of the TA is a primary key, but also is a foreign key that references the student. See that? It's both, right? The primary key is a foreign key that references the student. And notice that there's a cascade delete. That means that if my parent is removed, if the record for this student is removed, then the TA record is also removed. It would make no sense, right, to keep the TA record if I don't have an equivalent student record. Right? You just can't be a TA without being a student. That's what it says. Okay? And that's exactly what the object-oriented diagram says. Right? A TA is a student. Right? So foremost, the TA is a student, and then they're a TA. Okay? And that's what this captures, right? Yes, I have the same exact identity as the student, and I don't exist without being a student. Right? All right. What else? And here we are capturing the relationship of assigned, and the assignment. Notice that it's a many-to-many, meaning that this needs to be reified, right? This needs to be reified. This needs to be converted into a many-to-many table, right? A mapping table that has foreign keys both to the course and a foreign key both to the TA, right? So this needs to be converted into an assignment table that has two foreign keys pointing on either side. Also here, this registered, it also needs to be reified. See that? Replaced with a table that points to the student and points to the course, right? And so to that end, we have these two tables. These are two mapping tables, right? That they're associating. They have two foreign keys. One is a TA, right? That points to the TA. And the other one is the course. The course referencing the course number. See that? So it's pointing to both, relating those two records. Same thing with the register. Two foreign keys, one pointing to the student, right? And the other one pointing to the course, right? So this particular student is enrolled or registered in that particular course. See that? So that's part of the reifying. And again, also the assignment asks you to identify many-to-many relationships and to reify them. All right? So you would do something like that. Here's another example. Vehicles may be parked in the garage. So again, I'm highlighting here the nouns and the verbs. Every garage has an address. Some vehicles are cars and some are boats. Every vehicle has a unique VIN number and a power rating in horsepower. A vehicle has an owner. A car has a number of tires. A boat has a number of propellers and may have a name. So boat may have a name. So after a lot of analysis, you come up with this, something like that, right? Where you have a a base class of a vehicle, and cars and boat are inheriting from the vehicle. The vehicle is capturing all the things that are common with all vehicles, but the boats and the cars are capturing those things that are specific to the cars and boats. So we call this from these derived classes. We looked up, and those are generalizations. From looking from above down, we say that these are specializations, right? So these are special cases of that, or this is a more general case of these two, right? So depending which way you look at it, right? We refer to that. Also notice that a garage might contain multiple vehicles, right? So implementing that and providing a relational schema for that, we have the garage, we have the vehicle that points to the garage, saying, notice that there's a one-to-many, right? So a garage might have multiple vehicles. So on the weak side, we have a foreign key pointing back to the garage. We have a primary key, so these are some of the value fields. We have the vehicle being a base class. So the car and the boat are inheriting, right? Oops. The boat and the car are inheriting. So notice that they have primary keys that are also references to the vehicle, and they have a cascade delete, meaning that if the parent is deleted, I am deleted as well. Right? Same thing for the car, right? We have a primary key that is also a reference that if the parent is removed, I am removed. Okay. Association classes also can be implemented as mapping tables, right? If you have multiple flights and multiple frequent flyer miles, right? And so so in one place you're capturing the information about a particular flyer, particular passengers, right? That might have multiple flights, and you want to capture, right? As part of that association, you want to capture, how many miles, how many bonus miles you've captured for every particular flight, right? Again, we can't capture this in a relational schema. We need to reify this and convert this into a mapping table, right? That not only has foreign keys, right, but it also has additional information about the relationship, right? If the mapping table, if the table in between only has foreign keys, right, it's just a mapping table. But if that table not only has foreign keys, right, and mapping, but also has data, right, that specifies that relationship, we call that an association table, not just a mapping table. Okay. And here's the implementation, right? We have the flights and the frequent flyer miles. So they notice that they don't have any foreign keys, right? Because otherwise they would have to be arrays of foreign keys. We can't do that, right? So instead we capture an association table in between that has two foreign keys, one that points to the frequent flyer mile and the other one pointing to the flyers, right? And then plus the association attributes there, the base miles, the bonus miles, and whatnot. Okay. Company, person, here's another one. So this is just another example of doing it for an association class. All right.